Alright, so now that we've talked about bias and knowing what basically we shouldn't be doing, we're going to focus a little bit on then how can we collect a sample in a good way. There's many different methods that we could be talking about when it comes to sampling, but we're just going to cover a few in this course. The first three are kind of good methods that are used quite often. The first one is just what's called simple random sampling. And the biggest way I like to have students think about this one is that it's sort of a big raffle. So everyone has a ticket in their raffle, we pull out so many tickets and those are our winners, and basically that's our sample. So what this really means for us is that we're going to start with a list of everyone or everything that's in our population. So it's kind of where everyone has a ticket in our bins, right? We have a list of all elements in our population. I'm randomly going to select n of them. And I'm just going to represent our sample size here. So I might randomly sample 10 people, 100 people. I can just choose that number. These are your sample. A lot of people like this type of design because it seems very fair, right? Everyone has the same chance of being selected. But there's a couple of unrealistic things about doing a simple random sample. The first is actually what I said I started with. I have to start with a list of all elements in our population. So for example, going back to one of our bias populations, we were talking about having our population be, all residents of Boone County. So that means I need a list of all residents in Boone County. Maybe not the easiest thing for us to come up with, right? So the idea is great. The actual practicality of getting that list to begin with is a little tougher. Stratified sampling is a very small extension of it. It actually starts the exact same way. It does start with a list of all elements in your population. So that's not getting any easier for us here. Then there's a step in between here. Next, we're going to break this list into homogeneous groups that we call strata. And then we randomly choose a given number some from each strata. So what I mean by that, so maybe we take our population, we break it up into men and women. And I'm going to sample 100 men and sample 100 women. That would be an example of a stratified sampling. Now, an important thing about this, when I break it in to my homogeneous groups here, this can't be on your variable of interest. So what I mean by that. So if I broke my population into men and women, sampled 100 men and sampled 100 women. Idea seems great. Unless, of course, my variable is gender. Right? If I'm trying to figure out the percent breakdown of men and women in Boone County, and I intentionally sample 100 men and 100 women, I've now just forced that I'm going to have 50% men and 50% women, so I think it's an even 50-50 split. Right? So I don't want that homogeneous group to be my variable that I'm actually interested in, so I'm forcing some things to happen there. A systematic sample is a little bit different. It basically means that you randomly choose the first element and then sample every case thereafter. So for example, maybe I'm standing outside of a restaurant and I sample the first person that comes out and then every 10th person that comes out after them. Which is kind of a systematic way of choosing your sample. These are some pretty common methods that are generally thought to be pretty good, again, as long as you employ them correctly. Let's talk about a couple of other methods that we still see quite often as well and aren't necessarily bad. So we'll talk about when they can be bad versus when they can be good. So a convenient sample is just what it sounds like. I'm simply going to sample those that are convenient. And these are done all the time, so this could be, again, maybe I take a class poll because it's nice and easy because my students are right there. I could stand outside a grocery store and ask people questions. It's just nice, it's easy to do. Now, depending upon what you're measuring and how you do it, it could be good or it could be bad. So let's go for the stand outside a grocery store. Typically speaking, that probably sounds good, depending upon what you're measuring. So suppose I was measuring height of women standing outside a grocery store. My guess is we don't know certain sized women go to certain grocery stores, I mean, at least as far as I know, so that probably would be a pretty reasonable sample, nothing strongly biased for it. But if instead I'm trying to ask, which grocery store are you most likely to shop at, if I'm standing outside a grocery store, they're probably most likely going to shop at that grocery store. Right? So that would not be a good way of doing it. So again, it really comes down to what you're measuring, is if your sample can be good. A volunteer sample is, again, just what that sounds like. You simply ask for volunteers. And I'm going to specify a little bit more about this. So people seek you out. Normally it's the other way. I was like, oh, would you fill out my survey? Oh, would you fill out my survey? Right, people no matter what have to volunteer to fill stuff out. But when I talk about a volunteer sample, it means I don't seek people out, they seek me out to fill it out instead. So again, this you is the researcher. So some examples that fall into this category are, a lot of times you'll see news polls, call in and give us your opinion on this. If you've ever seen the website called Rate My Professor, people voluntarily go out and fill out things about their professors. Medical trials a lot of times fall into this category. And I'm going to refer to bumper stickers, and I'll kind of explain each of these in a little bit better way. So a news poll, so it might say again, kind of call in, give us your opinion on something. Rate My Professor, for those that have looked at it, what you'll actually see when you look at Rate My Professors, you generally see the two extremes. You see people that love a professor or they really hated a professor. So you do tend to see some biased answer to both news polls and Rate My Professor. Medical trials are a little bit different. So you maybe have seen ads in the paper of $2,500 if you participate in our sleep study, for example. So again, they're asking for volunteers, like in a sense that people seek them out to participate, but medical trials are nicer because they do have certain regulations that people have to go through, some screening and all that type of stuff, which is very nice. So even though you volunteer to be part of a medical trial, it doesn't actually guarantee that you get to be part of that medical trial. The last one is the bumper stickers. This is because I see them so often when I'm driving, of the bumper sticker that says, "How's my driving?" and gives you a phone number to call. You're surprised that's a pretty biased sample that we're going to get, because I haven't probably guessed that many people will call and say, "Oh, that truck made the best right turn ever." Usually you're going to get the calls that, this truck just blocked me off and cut me off and almost hit me. Usually you're going to get some negative calls with that. So with a lot of these volunteer samples I just mentioned, you can see that they are probably pretty biased samples. But as long as you know that, you can still get some information from them. So for example, if you've ever looked at the Rate My Professor, I'm not telling you to never use it, because you can still look for trends. Is every review out there negative about a professor? That's probably going to tell you something. Or it's like the bumper stickers, right? We know we're going to only get negative phone calls, so I could at least look, well, how frequent do those calls seem to come in? I have one driver who gets 1 a month and another driver that's getting 3 a week, right? That kind of tells me some trends. So if I know what I'm looking at, I can still get some useful information from it, even if it is slightly biased. It's knowing that it's biased that I need to have information about. That's a little bit about sampling methods. You can sometimes see multiple sampling methods, right? I can stand outside Kroger and sample every 50th person that comes out. So I'm doing a convenience sample at the same time doing this systematic sample that we have. So you can sometimes see a combination of both methods as well.